miles from Key West is Cuba, which is another country. It's an island, and it's a very beautiful country. Does anybody know how far it is from Key West?
I've heard it before.
I couldn't hear you.
I think I've heard.
Jack, could you speak up, buddy? I'd love to be able to hear you.
I think I've heard how far it is. It's just so just a few hundred.
I couldn't hear you. Somebody else was speaking, but say it again, Jack, with a little more volume if you can.
Well, I muted myself. I feel like I know it, but I can't find. Well, I can't really find it.
Okay. Well, that's okay. Now, guys, it's actually 90 miles. So less than 100 miles from Key West is the island country of Cuba, which is really kind of neat. So hopefully every day everybody will be able to get down there and see that beautiful country. So let's go and explore something. We're going to be talking today about a mathematician, and this mathematician's name is Mr. Pick. Now, when I first heard the name Mr. Pick, I said to my teacher, is he famous for his nose? And my teacher didn't find it very funny, but I thought that Mr. Pick must be famous for his nose. But apparently that was not it. Mr. Pick was actually playing with figures. And what he was doing, he was playing with squares and rectangles. And this is what he did. So everybody look at what I'm doing right now. And let's do another one. And then let's do another one. So I want you guys to write on your paper these three rectangles with their dimensions. So I'll give you a hint. The first one is a 3x2 rectangle. And I'm going to ask you.
on the back?
Say again, or it's just on any piece of paper.
Oh.
Yeah, don't write on the packet yet, because every page is important. Right? I've asked everybody to unmute so we can hear people when they have to share, which is great. And uh-oh, that was loud. Who can give me the dimensions of the second rectangle? William?
4, 4, 5, 1.
Beautiful. And the dimensions, another person. Wait, someone make a really loud noise with their paper. And if you can try to figure out who you are, that would be awesome. Jonah, go for it.
7x3. So that would be a 1x2.
Does anybody have a different dimension? Gabby?
That would be 6x2.
Yeah, so Jonah, I want you to look at how I count this. 1, 2, 3, 4, 5, 6, and 1, 2 units. Now, what you did, Jonah, is you counted the dots. 3x7 dots, but that's not the dimensions, because the dimensions are the length. So Jonah, does that make sense? Okay, cool. Now, everybody give me now the area of each of these. Who can share? I'm going to ask first for Olivia. Olivia, the first rectangle, go.
Yes.
Olivia, only Olivia, you have to unmute yourself, please. Also show yourself so I can see you. And on 3, Olivia, 1, 2, 3, and go ahead, Olivia. 3 times 2, honey. All right. Sunyi. Maeve.
6.
And Maeve, what'd you get? And Maeve, keep yourself unmuted so you don't have to touch the computer when I call on you. Come on, unmute, unmute, unmute. You can do it. You can do it. How about you, Avery? How about you, Tess?
6.
Yep, except I didn't hear anybody say something really important. Jack, do you know what we need to add after the number 6?
6 square units.
Yeah, that's my man. So these are 6 square units. How many square units is the next one? On 3, 1, 2, 3, go.
4 square units.
And finally, the last one, go.
12 square units.
Now, Mr. Pitt found something incredible. What Mr. Pitt did is he started to count the interior dots, and he counted the perimeter dots, and he found something really interesting. First of all, who can tell me how many interior dots in the first one? Go.
2.
3. How many interior dots in the second one?
0.
How many interior dots in the third?
5.
All right, now,
205.
how many exterior dots? Don't say it out loud. Don't say it out loud. But the best way to do this is to kind of think of them in groups. Don't say it out loud yet. Exterior dots, perimeter dots, on 3, 1, 2, 3, go.
8. 12.
10. He took 10
10.
and he divided it.
Oh.
to
5.
How many border dots, how many perimeter dots are there on the second figure? Don't yell it out. Count on 3, 1, 2, 3, go.
10.
And we divide that by 2. Then what about the last one? Please do not call it out. The number of perimeter dots on the last one, and on 3, 1, 2, 3, go.
16. 14.
If you got it,
8.
you got it right. Now, look at what happened. When he did 2 plus 10 divided by 2, somebody's yelling, please stop that if possible. 2 plus half of 10 is what?
7.
0 plus half of 10 is what?
5.
5 plus half of 16.
13.
13. 13.
Now, we can make a connection between the numbers that Pick got and the numbers of our actual area. What do you think happened? Sarah, do you have any thoughts?
I was just noticing that every number of the perimeter of dots is one more than the area.
Whoa, that's kind of interesting. So Avery, what do you think Mr. Pick said we need to do with the 7, 5, and 13?
I don't really know.
And Mark, what about you?
I found that if you calculate the 3, 2, and the 2 dots in the center for the first one, that equals 7, and 7's on that, and 7's on the parameter dots.
That's true. But who can tell me how we get an area of 6 from 7? How do we get an area of 4 from 5? How do we get an area of 12 from 13?
-1.
Yes, everybody put a -1. And if you subtract 1, you get the area. Now, this, everybody, is called Pick's theorem. Everybody now go to their page 1. Page 1 shows you what Mr. Pick discovered. He said that if you take half of the perimeter dots, you add them to the interior dots, and you always subtract 1, you will get the area. But can I ask you a question? Why do we need to do that with rectangles and with triangles? Didn't we learn last week how to multiply the base times the height? Jonah, what do you think?
Oh, Mr. Kramer, I wasn't raising my hand.
Okay, does anybody have an idea why Mr. Pick came up with this theorem? Go ahead, Gabby.
Oh,
Go ahead, Gabby.
I actually can't think of anything.
All right. Does anybody else have an idea? Go ahead, Avery.
Maybe because it was easier. I don't really know.
Well, I'll tell you something. Are all polygons rectangles and triangles?
No.
No.
So would you like to see what Mr. Kramer created just last class?
Yes.
What do you think of my crazy figure?
Oh my goodness.
Well, guess what? Mr. Pick's theorem would allow you to find the area of that absolutely crazy figure. Now, I didn't even highlight the area. Do you know why? Because it was actually too hard for me. I couldn't figure out a way to do the entire area, but Mr. Pick's theorem helped me figure it out. Would anybody like to see the area of this figure?
Yeah.
Yes.
Okay, you ready?
Yeah.
By the way, does anybody have an idea of what it is?
Well, can it be a guess?
Yes.
Doesn't seem in the hundreds. Actually,
It's about like
today I've been on a 102 streak.
What about you?
107.
102.
I have a 107. How about you, William?
25.
Only 25. Okay. Anybody else? Tess, what about you?
95.
95. William's iPad, what about you?
102.
102. And Jack, what about you?
No.
I think 102.
Okay, try not to anchor yourselves on other people's answers. Try to think independently, okay?
My prediction is about 140.
And Kelsey,
98.
and what about Bayram and Jonah?
I think maybe 148.
148. And Bayram?
I think it's I think it's 142.
And the actual answer is 142. And let's go through the calculation. Mr. Creamer literally counted all of the interior dots. And the way I counted them is I started with the bottom row and I literally counted across every time I hit an interior dot. Then I went to the next row. And then I went to the next. And I got 106 interior dots. It was actually much easier to count the perimeter, the border dots. It was easier. And I got 74. Half of 74, everybody, is what?
36. 36. Oh, yeah.
Now, some people said 36. I'd like to
37.
share with you.
30.
Hold on. I'd like to share with you my distributive property. Pretty quiet. My distributive property algorithm for figuring out half of 74. I partitioned 74 into 60, 10, and 4. And then I took half of 60 is, everybody.
30.
Half of 10 is, everybody.
5.
Half
And
of
2.
4 is, put them together.
37.
And therefore, I had to add 37, but don't forget to subtract the 1, which is 36. And Bayram was right, 106 plus 36 is 142. Now, Gabby was the first one that got into the right region of answer, and then Jonah with 148. And it's really amazing, guys. There's no way to do the area of this without Pick's theorem. Mr. Pick really changed the world. Now remember, it has nothing to do with his nose. Nothing at all to do with his nose. Now, I want everybody now to go to page 2 in their packet. Now, I created a picture of what I call Africa. Now, I'm not sure if it's a great picture of Africa, but it's a good picture of Africa. So I would like to know if you guys can please figure out the area of Africa by doing half of the perimeter dots plus all of the interiors minus 1. All right, everybody go. Oh, and by the way, guys, everybody look at my algorithm. Look how I do the interior dots. I break it up into little rectangles, and it really helps. So you don't have to count by ones. Counting by ones can be fun, but I think counting by 2s, 3s, and 4s, way more fun.
Well, I like counting by 10s and 5s.
Well, you and I are in the same boat. I love counting by those numbers. Now I'm gonna go get some water. I want everybody working and nobody say the answer out loud, please. Thank you.
Can we chat it to you?
Yes, you do.
send this?
If you go to the chat feature, that is the easiest way to send. And let me check all of my chats.
Wait, are you supposed to count the square units?
Well, no, you're supposed to count. You're supposed to count the interior dots, and you're supposed to add the interior dots to half of the perimeter dots, and then you're supposed to subtract 1. So who can tell me how many interior dots they got? On 3 interiors, 1, 2, 3.
29.
26.
I get
26.
I got 26. Now, how many perimeter dots did you get? On 3, 1, 2, 3, go.
9.
9.
You got,
30.
quiet, please. Don't be talking.
9.
Did you get 18 perimeter dots and then divide by 2? Yes.
It's
Yes.
31.
So 26 plus 9,
It's 31.
1,
No, it's 30.
and on 3, 1, 2, 3, go.
34.
34 square units. Now, I'm going to look now to see how many people were able to get to the right answer. So I got, wow, nice, Mark, good. Wow, you got really,
I
everybody.
got 31.
William's iPad did great.
I got 31.
Jack nailed it. And yeah, Avery got so close, and Jonah nailed it. Gabby, wow. Everybody got really, really close. Now, the next continent we're going to do is Australia. No, we're not. We're actually going to do the Flying Elvis. Go to page 3. And on page 3, I want you guys to do the Flying Elvis. This is the Patriot symbol. And be very careful counting your interiors, because a lot of people did really well, and some people were off by just a little. And it's really easy to miss. And I'm gonna draw, I don't really see a lot of good rectangles to work with here on the interior. Maybe that one. That's about it.
What about triangles? Can you use triangles?
You know, that's actually a really good question.
Mr.
I
Kramer?
actually, you know what I'm thinking of? On the triangles, I'm thinking you could like use this. And then maybe you could create a square around one of them.
What is this?
Mr. Kramer,
Yes.
some of them are super close. I can't really tell if they're like if they're inside or outside.
Can you tell me the location of the one that you're focused on?
Well, like there's the ones at the top that are next to the rectangle.
This one here?
Yeah, those ones. I don't know if they're like outside or inside.
These are on the perimeter. These are on the inside. Avery,
Okay.
what do you think, buddy?
I figured out why I missed. Because I did half of the inside dot.
Oh, Avery's so cool. That's so cool. Now, you know, Avery, that Mr. Pick, he tried so many things until he figured out his theorem. And that's what mathematicians do. They try, and try until they solve it.
Okay, now I'm gonna start. Mr. Kramer,
Yes.
Can you check
for the perimeter dots, I'm trying to divide 25 into 2, but it's not going to be a whole number.
That's okay, but I would recount. And by the way, guys, I have a little method of doing perimeter dots. I like to circle one of them so I don't forget. So as I count around, I never double count.
You check my answer if it's correct.
Yes, in just a moment. Can anybody give me the number of interior dots? On 3. 1, 2, 3, go.
25.
35. 14.
Guys,
14.
guys,
26.
guys,
It equals 27.
I
It's
got,
27.
hello, please do not.
14.
Only 14, guys.
I thought 14.
I don't know where your numbers are coming from. If you could tell me where you got anything different than 14. I got 6, 3, and 1 make 10. And then I got 4 more.
7. It's 27.
That is 14. Now, the perimeter dots. On
26.
3. 1, 2, 3, go.
26.
6.
28.
Half of, wait a minute, let's count it again. 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, and 26. And 26 divided by 2 is?
13. 13
And-
plus 14 equals 27. It's 27.
But don't forget to subtract the 1. And if you subtract
26.
1 from 27, you get
26.
26 square units. Now, guys, that one was a little bit easier than the other one, but now we're going to do the headless man. Are you ready? I call him the headless man. So go to page 4. And you may find that there are some special ways to count. For instance, when I look at the interior dots, I see this beautiful rectangle. I also see some symmetry that is going to help me with this. So I want you to use symmetry if you can. Use my method of marking one of the dots to start, and use symmetry if you can. Go ahead, Olivia. Why don't you turn around and pick up your pencil and get going?
Nine.
And I'm going to be checking the chats now.
Hey, Mr. Kramer,
Yes.
can you have an odd number when you're doing?
Oh, you can definitely have an odd number. And if you have an odd number and it's the perimeter dots, then you will have a half.
Well, I have a question.
Please.
So if you look closely at where the arm bends, the dot right there, is that on the inside or out? Is that on the interior or in the perimeter?
And which one is that? Can you direct me with north, south, east, west, right, left, up, down?
It's up. It's further up on the man, and it's towards the right, but then the same thing happens on the left too.
So is it this one?
Yeah, is that on the inside or on
That's
the
that's a perimeter dot. And you know it's a perimeter dot because that's what the outside figure does. It goes from this dot down to that dot, from that dot down to that dot. So all of these are considered perimeter dots. Gabby, that was a great question.
Okay, because it almost looked like it was barely inside it.
Right. Okay.
Yeah, I got an
Now, who wants to give me the number of interior dots? On 3. 1, 2, 3, go.
16.
I got 16. And I don't know if anybody did this, but I looked at 2 and 2, 2 and 2, which is 8, and then the 8 in the middle. So that's the way I came up with my 16. Did anybody come up with the number of perimeter dots?
16 and a half.
Oh,
For the
now,
perimeter dots, I got
you can have a half number of perimeter dots, but when you divide it in half, then you can. So what is the number of perimeter dots?
31.
I'm gonna see
32.
34. 34.
Yeah, now everybody, I want you to watch this. Mr. Kramer decided that he was only going to count half of the perimeter dots because there's perfect symmetry in this diagram. And when I counted just half of the perimeter dots, I got 17. That means that if I double, and I'll count them again, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. If you double 17, you get 34. But of course, if you take half of 34, you get
17.
And don't forget to take away 1. So 16 plus 17 minus 1, or 16 plus 16. On 3, everybody, go.
32.
32.
Wow. And a
32.
lot of you chatted to me the correct answer. Now, they're going to get harder. I give you one of my favorite creations. I call it the bird. It's on page 8. I call it the bird. And if you think it looks like something else, that's perfectly fine. Now, Jack, your brother thought that it looked like somebody that had been zapped by electricity, which I thought was a brilliant rendition of that picture. I never saw that.
But it also looks like a bird with a mohawk and then with this crazy tail.
Yeah, that's, of course, that's its tail, and these are its wings, and its very funny head and bill. But of course, you can see something completely different.
It looks like a grasshopper with a funny tail to me.
Oh, that's kind of interesting.
It looks like clovers.
It looks like the leprechaun if he was weirdly shaped. The hat's like a clover.
It looks like a dog.
Yeah, it's
I'm gonna go to the restroom.
It looks like a
Yes.
dog.
Now, guys, I want you to start counting interior dots, perimeter dots. Don't forget to take
Mr.
half of the
Kramer?
perimeters, and don't forget to subtract 1. Yes, sir. Question.
Where's Australia?
Oh, I haven't created Australia just yet, but I'm working on many different pictures. I really love to do, these are called lattice drawings. And what's interesting about them is they have to go from point to point with straight lines. So that's why they're called lattice drawings.
Well, can I make my own?
Oh, trust me, we will get to do that before the end of class. Sarah?
It's kind of hard to see it on the paper and a little bit on the screen too, because it's highlighted. When you, right near your mouse, if you go down 2 dots.
To where?
So right, if you go up a little bit, see that section? There's, where's the dot?
Are you having trouble with the interiors or the exteriors?
Exteriors. I can't tell which ones are in and which ones are out.
Okay, so
Because-
let me circle for you all of the exterior dots.
The green's covering some of my lines. The green's covering some of my lines. And that
So
means
Sarah, is that helpful?
Yeah. 60.
5. 1, 2, 3, 4, 5.
But I think I can kind of see it because I can see yellow, a yellow thing. So
6.
And guys, do you know that Mr. Pick came up with this discovery in the year 1899? So it was over 120 years ago.
Mr.
Really
Kramer,
interesting. Yes.
I put my answer in the chat. Is it correct?
I don't know. I've got to figure it out myself. So I'm going to do that right now. And we're gonna share in just a minute.
Can I show you something?
Hold on one second. I'm counting 5 seconds.
Will you check mine?
Mr. Kramer,
Yes.
there's one spot where I can't see where the dot goes.
You'll have to describe it to me the same way Sarah did.
It's down. Well, if you look at my paper,
Yeah, so I don't agree with anybody's answer yet on these. And are you going to describe to me what you're having trouble seeing?
there's no dot because this is covered in green.
I cannot hear the person who is speaking, so you'll have to speak more sort of into the microphone.
Is my answer correct?
I don't have any correct answers yet.
Was mine
Kelsey's is really close. Now, guys, how many interior dots did you find?
17.
I found 17 also. How many perimeter dots did you find?
26.
Nope.
I mean, 50.
I found 51.
54.
52. And half of 52 is,
26.
and don't forget to subtract 1. And if you add 17 to 25, if you add 17 to 25 on 3, guys, what do you get? 1, 2, 3.
42.
42 square units. So Kelsey was the closest. She got 43. So guys, this is hard. One would think it's really easy to count. Now, I'm going to show you one that's really challenging. And I love these. On page 10 is one of my favorite ones. And there's a lot of symmetry going on, but not exactly. Now,
Mr.
I
Kramer,
want, yes,
on mine, it says at the top, this thing is marked page 10, but at the bottom, it's page 9.
yeah, that I may have made a mistake on that. I apologize. So Just go to the picture that you actually see. Now, guys, this is a lot of fun. This is like a, I don't know if you can see the faces. It looks like somebody with a, and this is their mouth right here and their nose, but they've got actually two noses. So they're a little funny looking. Anybody have any questions on this?
I kind of, no, it kind of looks like a strange I think a little.
Looks like a reindeer because those four ones on its top look like antlers.
Ooh. Now, guys, interior dots. Who's got the interior dots already?
Perimeter dot.
Come on, what did you get for the interior dots? Who's got it for me?
I got 15.
I got 15 also. Now, perimeter dots. Remember, mark 1.
I sent in.
Mr.
Wow.
Kramer,
Hayden, you got it, kiddo.
Mr. Kramer, did I get it right?
William got it. And Maeve got it.
Mr.
Wow.
Kramer, did I get?
Oh, Tess, you are like so unbelievably close. Mark, no.
did I get it?
You're off by a slight. How many perimeter dots did you guys find?
46.
46.
46. So
43.
Hayden, you got 46. And what is half of 46, everybody?
23.
23.
And what is 15 plus 23 minus 1?
37.
37.
And 37 square units is the answer. Now, are you ready to make your own? Now, when you make your own, it does not need to be as crazy as Mr. Kramer's. Now, where is the one that I made? Where is that crazy one? No, it wasn't there. Wasn't there. Where'd it go? Well, I seem to have lost my crazy one. Oh, maybe, oh, here it is.
Page 11 is a crazy one.
You don't need to make anything as crazy as this. But what I want you to do is try. So go down to page 13 or 12, the ones that are empty. Use a ruler. If you do not use a straight edge, you will not be able to solve it.
Mr. Kramer, I made a video game controller.
Really? That's cool.
Mr. Kramer, what if we don't have a ruler?
Then use a straight edge. By the way, I can also show you something else. Everybody look at the screen, please. Everybody look at Mr. Kramer's paper. You got it? Everybody look. Everybody look up on 3, 1, 2, 3. Take a piece of paper, fold it in half, and fold it in half again. And then fold it in half again. Guess what? You've created a very nice straight edge that you can use to do this activity. And this, I wish I could just hand it to you. Here you go.
Mr. Kramer,
Yes.
So do we basically just make any shape we want?
Anything. Anything that pleases you. Mathematicians that please themselves with beautiful drawings, they become great mathematicians.
We doing something inside?
Oh, that's a great question. I think not just yet.
Does it have to fill up the whole paper?
Nope, it can fill up whatever you want.
Mr. Kramer,
It's
this is
your
my
creation.
shape.
Oh, that's cool. Now see if you can figure out the number of interior perimeter dots and take half of the perimeters and don't forget to subtract 1 from the total.
I mean, Mr. Kramer.
Yes.
So, on my brother's work, so in my brother,
Jack, you're going to have to speak up like a lot because your microphone is not very strong right now.
so my so I'm on my brother's paper, and so I can't you do on page 13 and 14.
Yes.
So I can, and he drew on it with pen.
Ah, yeah, that's not going to work. That's not really what mathematicians do. They need to use pencil, and that way you can erase, because we all make lots of mistakes, us mathematicians. So you can use any piece of paper, Jack, and create a drawing and then put it on graph paper later on.
Mr. Kramer,
Yes.
I made mine.
I finished mine.
Oh, Sarah, that's beautiful. Now start counting and figuring out the Hayden, that's absolutely awesome. Tess, can I see yours?
Oh, I finished the.
Oh, that's beautiful. And make another one, Tess. Now that you're done with that one, make another one. If you're finished with one. Isabella, can I see what you've drawn so far? Oh, wow. That's beautiful. Jesse, what about you?
I don't have my pages printed out.
And well, Baram, you got to work on that, buddy. But you use a piece of graph paper if you can. Alexander, I can only see the top of your head, which is usual. But if you can sit up and show me what you are drawing, I would appreciate it. And if you can unmute yourself, then you could speak and I can hear you.
Mr. Kramer, I finished mine too.
Can I see it?
Mhm.
Mr. Kramer,
Yes.
I counted mine, but mine keeps ending up with an uneven number.
So what were your numbers? Tell me your numbers and I'll see if I can help.
It's just my perimeter number is 49.
So you got a perimeter number of 49.
Yeah.
Now, when I look at 49 and I partition it, I like to say maybe 40 plus 8 plus 1. Now, if I take half of 40 and 8 and 1, can you tell me what is half of 40?
20.
What is half of 8?
4.
And what is half of 1?
Half.
And if you add 20 plus 4 plus half, what do you get?
24 and a half.
And that is half of 49. So you
You're
have
allowed
to
to do
now, you have to
fractions?
add that to your interior dots.
Wait, what?
You have to now add that number, 24 and a half, to your interior dots and then subtract 1. And that's your job.
Gamer,
Alexander,
I'm
are you able to,
drawing.
where are you, buddy?
Let me bring up my picture. So the camera might be a little bit glitchy with the pictures
it's not
because I
glitchy.
don't
It's
have
not
so much
glitchy.
light.
It's not glitchy. Just show it up. Just
Okay.
pick it up.
I'm not done with it. It's supposed to look like a penguin.
Oh, wow. Keep going, buddy. Keep going.
Okay.
I love it. I love it.
Mrs.
Yeah.
Kramer, I'm finished drawing.
Did you finish counting your dots?
No.
Well, do that now. That's your job. You have 4 minutes to do it. Maeve, may I see you? Oh, Maeve, hold it steady so I can see it. And hold it a little bit closer to the camera. Wow. So Maeve, why don't you create another one, something even more amazing?
Mr. Kramer.
Elsie, can I see what you've drawn?
Okay. I started working on it.
Oh, that's
I
beautiful.
tried to draw flowers.
That's amazing. Avery, wow. Incredible. Who else can show me? Sarah, have you finished yours yet?
I'm finishing painting. The inside is very big.
Well, you should watch Mr. Kramer's inside and look how I'm using rectangles. I found there a 3x4 rectangle of dots.
Oh, smart.
And I'm trying to use rectangles to help me count. Look at all these beautiful rectangles, guys. I'm feeling like it's making my job easier as a mathematician to find beautiful rectangles. And then when I don't find rectangles, I can just count them by the ones. So 24 plus 10 plus 15 plus 10 plus 10, 12 plus 6, 1, 8,
16, 1, 2, 3, 4, 5, 6.
21, 22, 23, 24, 25, Mr. Kramer. 30, 31, 32, 33, 34, 35.
Mr. Kramer, I finished mine.
Okay, somebody had a question for me. Go ahead. If you have a question, go ahead and ask it.
I just wanted to show you that I finished mine.
Oh, awesome. And try to create something new. So I'm still working on my interior dots, guys. This is really hard. So I have 30,
Mr. Kramer.
40, hold on, 50, 60, 70, wait, 30, 40,
99.
80,
I finished.
wow. I have 124 just my interior dots. Who had a
Mr.
question for me? Who had a question? Go
I
ahead.
did, Hayden. So, are we supposed to do are we supposed to, divide the interior or the perimeter?
Well, what do you remember about all the previous ones that we did?
The perimeter?
We take half of the perimeter dots plus the interior dots and we subtract 1. Now, guys, I'm really proud of the work
My
you've
answer
done.
is 126 square units.
Wow, Jonah. Now, Mr. Pick would be very, very proud, I think. And guys, I'm going to have to say goodbye until next week. I hope you enjoyed the great discovery of Mr. Pick, and we will see you next time. Bye, guys.
Bye.
Bye. Bye.
Yeah. Mr. Pick dead?
I like your glasses, Kelsey.
Isn't Mr. Pick dead?